Hi, welcome back to my channel. This is a video on how a programming error in a React component led to a major failure of a Cloudflare service. And I am doing this video because it ends up providing some interesting insight into how a concept in programming language semantics had a real impact on why this error occurred. And it's an interesting example of why of what seems to be very abstract concepts in programming language semantics can actually do have real world consequences and real world applications. So as a way of background here, Cloudflare is a basically they do a lot of network services for denial of service mitigation and stuff like that. They work at very large scales in terms of network traffic. So they're an important part of the internet and they're a big player. And so this outage was very notable in how many customers it impacted and the issues that it caused. And the nice thing about this is that they actually provided a very good breakdown of what happened, so people could see, oh, by the way, this was this React error that we did that basically because we introduced this error, one of our APIs became overloaded with calls, and there's a cascade of effects. And very good article about what happened here. So it's this error in the React component that I'm going to go in more into. So there are some responses to this. First of all, that this was a rookie mistake. I'm gonna visit back on this later, but a lot of people are pointing out it's like, oh well, everybody knows you can't do this thing, which is if you put objects in the dependency array and those objects keep getting created over and over again, then it's going to assume it's changed and it's going to fire this off and stuff like that. This bug happens, so you should really need better programmers out there. I'm good at React. Why was this happen? Well, everybody needs better programmers. And not only that, but these aren't just a bunch of juniors doing this. So that's really kind of a non-starter in my regard. But that's sometimes what people do is like, oh, they just need better programmers. And like I said, as a response is very rarely true. The second one was, and this is an interesting wrinkle that we are dealing with now, is like, well, this may have been an AI mistake, that this was some AI code that got generated, looked pretty good, passed the sanity checks, and really wasn't reviewed to the level that it needed to be. And that's a more interesting type of thing. That is much more of a something that does need to be looked into. That are you really using AI tools appropriately? And I will not get into why AI tools may or may not be a good thing. I'm going to do a separate video on that. But this is something that we're dealing with now. The response three is also from the operational side, which is something I don't have a lot of experience with. Things like DevOps and all that. Is that, of course, these types of things happen, but how could you set it up? How could this get into production, basically, without you don't do things like gradual rollouts, testing, all this kind of stuff. All of those were excellent points, and they talked a little bit about how they're going to do better in being able to do those types of things, even when these errors do hit production, to be able to respond to them more quickly. And so, but again, from my standpoint, not something I know a lot about, so not something I'm going to go into in more depth. Response number four was, of course, basically a lot of people are like, "Oh wow, React allowed things to have React screwed up. That's surprising." And if you watch my channel, I've been very critical of React and a lot of web frameworks and JavaScript and TypeScript in general. A lot of people are critical of that language, and I'm not going to try to rehash that stuff here, but there is something that I think is interesting that I want to kind of look at as a programming language person and kind of the insights that's going to provide here. And so again, the background is that React builds this thing called the dependency array. And when certain parts of it mutate or change, it's going to use that to say, oh, I need to rerun certain code. And what that code might do is like update things on the client page. It also might go off and make API calls and so on. And so in this case, knowing when two things have changed is key. So a big part of this is that, well, how do you know when two things are equal? Because if you want to know if they're not equal, you need to know how they're equal. So that's really important. And the notion of equality in programming languages is actually a fairly complicated one. And it comes down to this. Let's take a look at how it works in JavaScript. Okay, JavaScript has very few immutable types. Most values are objects. And objects are considered equal if they occupy the same space in memory. If you have two variables, x and y, and they both are both objects, and x and y are both pointing to the same thing in memory or aliasing the same address in memory, then that's when they're considered equal. Okay. So what this leads to is that JavaScript has things like numbers. Numbers are mutable, so one is always going to equal one. The string foo is always going to equal string foo. But the bottom is true, where if you have an object with just a single field in a count and that has a value of one, that is not equal with an object in it with a count with a single value of one. These are two different objects. They live in two different parts of the memory, and therefore they are not equal as far as JavaScript is concerned. But there is a notion of structural equality that is also very useful. And what structural equality is that it says, okay, two objects are the same if all their values are the same. And in this case, if I had this special thing here, this is kind of the this operator here is not the standard type of thing, but I'm just using that to say, oh, this is structurally equal, so you know it's not the same as the JavaScript equals. And so these are structurally equal to each other because they have a field called count, and in that field that has a value one, and the other field has a value one, and one equals one, therefore they're structurally equal. Okay. Structural equality is what would work best in React, right? And in fact, it's kind of what it wants to do. It really wants you to build up state out of immutable types of things. Because if you put an object something in there, it really doesn't do the right thing. And it can be very easy for that to kind of go off the rails. And the thing about it is that it can't also, because of other JavaScript issues, it can't go off and say, oh, no, wait a minute, you can only put these types of things in there. You can't just put in just a random old object, because JavaScript makes that difficult to do as well. So there's kind of thing that says, well, if you do this, and you have to be aware of doing this. So there's kind of this knowledge of what's going on about what you can add to this dependency array. The thing about it is that an additional wrinkle to this is that I gave that notion of structural equality that is used, but in reality, structural equality is much more tied to the type, is specific to the type, and it's more complicated than the definition I gave before is. And so you can't just have this notion of what a default structural equality is, where every member is equal. Because for certain types of objects, that doesn't make sense in terms of how the semantics work. And I'll give you an example here. I'll just use C sharp syntax. But basically what it is, assume I have a class that's decimal, and it has these three properties here. It has the whole value, the fractional value. The whole value is what appears before the decimal point. The fractional value is what appears after the decimal point, but also this notion of precision. And you see here that precision is like this get only type of state here. And what that does is that represents how many decimal points are significant here. So here's the interesting thing about that. If you look at this, structural equality has to be specific to this class because the two decimal objects are structurally equal with their whole and fractional parts match. The precision doesn't matter. It just restricts the possible values of the fractional part in terms of creating them. That's right. But it doesn't matter that, 12.1 with a precision of 3 is 12.1 and a precision of 4. You want those to be the same thing because they really do represent the exact same value in the terms of domain. Okay. So you have to have a specific set of, basically, you can think of it as an interface or basically a way of doing this. If you're in Rusting, it would be a trait potentially. You have to have a common way of saying, how do you make this happen? How do you allow structural equality to be done? Now, React could have done its own thing here. And it's interesting that they did this, and I'll get back to it. Which leads to this error occurring. But the thing about it is that sometimes you just don't want to introduce your own ad hoc way of doing things versus waiting for the language to kind of catch up. And so there's arguments on both sides of why this would happen. Just to give you an example, in C Sharp, what C Sharp does is it has this notion of what's called I-equitable, and it's a generic type of interface. And that specifies the operations you need to do for structural equality checking. And then what it is that if you really need to go back to say, oh, do two objects really have the same location? There's a static method on object called reference equals that takes in two objects and will return true if they actually are in the same type of thing. So you can always go back to this shallow quality, or basically do they occupy the same space, even though they implement I-equitable. And other languages do this in their own way as well. The thing about it is that in my case here is that React should have done the right thing here, even though the lack of standardization in JavaScript around structural equality is a major roadblock. but it's not arguably one for React not to address this issue. And the reason being is that I was looking through this, and everybody has made this mistake. Everybody has made this mistake. It's so common that it kind of seems like a rite of passage. And if something like that becomes that common and can have this much of an impact on a code base, you need to have a way so that it doesn't happen. You need to go ahead and pull the trigger and say, you know what, we just can't rely on documentation for this. You have to do some way to make sure that this doesn't happen. There's lots of different ways of doing it. One, you could come up with your own set of interfaces that might complicate things. You might build a compiler tool to do this or a linter to do it. The reality is that you should ultimately really do in the code. The code should not allow you to do this. It should fail as soon as possible, and warn you about this kind of thing, because ultimately JavaScript is not something that you can just rely on static typing to catch all the errors. Things can still sneak through. And there's lots of these kind of examples, but this one really pointed out to me is like, this is something that was so fundamental and still hasn't changed. And there's still really no fix for it. And that seems really surprising to me. And I think I have some understanding of why. There might be a potential in which doing this might be too programmatically or resource intensive, that it might slow down the checking of the dependency array. But, you'd have to kind of, in my case, you'd have to prove that that was going to be an issue before you really fell back and saying, well, just don't do this. So, because of just how common it is. And not only that, but the thing about it is that you really end up having to break down your state into like some really, really small chunks, or be really careful about how you manage it. And that gets a little bit ridiculous. So if you want to do anything like use any sort of composite type, as a state in React, it just doesn't really work as well as you would want it to. So you end up kind of doing things where I've seen a lot of people just basically the state ends up being a lot of, well, it's ultimately just a string or integer, or all these other types of stuff, because they want to try to avoid this problem. And so, again, there's better ways of doing this. So in summary, what makes this interesting to me is that when people talk about these programming language concepts, they can seem incredibly abstract, but they have real world applications and impact. And this is just an excellent example of that. Anyway, thanks for watching. And if you do like this video, please like and subscribe.